So good morning, everybody. Today is Saturday, and today we are having the presentation for regarding the mode switch in the pacemaker. This algorithm is very commonly activated from regarding the arrhythmias, which device read and what we read on the ECG is totally different. Device is more like a robot. It has been given some instruction, and it follows that instruction very religiously. So whenever the parameters are falling in the particular algorithm, it immediately read it according to the set parameters. Mode switch is one of the algorithm which detects the rhythm problem, and we most of the time it is for the atrial fibrillation, atrial flutter, or atrial tachycardia. So it captures the event and immediately change the mode. So today with us, Mr. Anand from Medtronic, and he will be giving the derivation about the mode switch. So Anand, over to you. Yeah, 1 minute. Yeah.
Yeah. Can I start? Sure. Sir. Thank you so much, sir, for the opportunity. So, team, myself Anand from India Medtronic. So, I start with the mode switch algorithm from Medtronic. Yeah. So actually, this is the clinical need for mode switch. Like, what is the? I mean, we all know the pacemaker, dual chamber pacemaker. It is going to operate in either DDD mode or EDR mode. So most of the times it will be in the tracking. So this the main clinical need for this device is it's going to track the atrium and it's going to pace the ventricle. So that is a major thing. So in this scenario, why the mode switch is important? So like at some time we may have the atrial arrhythmia in that thing. So what the device will do if there is no mode switch on, then what device will do? It will obviously track the atrium at whatever the rate it goes, and it will pace the ventricle at the maximum tracking rate. So it will cause unnecessary symptoms to the patient. To avoid that, so those companies came up with an algorithm called mode switch. So like what it will do when an arrhythmia, like in atrial arrhythmia comes, the device will switch the mode into non-tracking mode. So which is DDIR for Medtronic. So other devices, like I mean, in all aspects, if you go, it will go into non-tracking mode. So this is the overall reason for this algorithm. Let me go into the next things. So yeah, whatever we seen here, it is mentioned here. So the pacemaker will automatically reprograms the mode to non-tracking mode, which is DDIR. So to prevent the pacemaker reacting to the fast sensory beats in the atrium to pace the ventricle at maximum tracking rate. So the second thing is, yeah, here like the overview of the Medtronic algorithm is, so Medtronic will before stepping into the mode switch, it will see the last 7 A to A interval, because we are going to see in the atrial cycle, because we will see the 7 A to A intervals. So that atrial rate which is exceeds the detection rate, then the device will go into non-tracking mode. Like in future slides we'll see deeply how it is going to do in step by step. So, and I just wanted to highlight here some of the clinical studies has demonstrated. So, this Medtronic's 4 out of 7 mode switch algorithm will respond in 2.8 to 3 seconds, which is one of the fastest like, in switching that mode. And so obviously there is one note. So mode switch is not recommended for the patient. So which is like have chronic refractory AF, because you already known the patient has chronic AF. So then there is no need for putting into mode switch, whether we can go with the direct VVI mode or VVIR mode. So that is an highlight here. So let me go into the next slides. Yeah. So here we will see how mode switch is going to work step by step. So here we are programming our normal detection rate of 175 beats per minute. So that is 343 milliseconds in terms of EP milliseconds. And what it will do, let me see. Let me show you here. So now we are already seeing the if A to A interval which is lesser than 343 milliseconds, which is more than 175 beats per minute, the device will switch into non-tracking mode. Here you can able to see this. One second, let me open this one. So here, this AS2, this AS interval is 300 milliseconds, which is obviously lesser than the detection interval. So then what it will do, the device will switch into mode switch. So this is how it will work. The step 2, it will check for last like 7 interval, 8 to 8 intervals. So let me show here. So this is one of the Medtronic's EGM strip. Whether you can see here the atrial, it's a summed EGM. So both atrial and ventricular EGM is summed here, and the marker channel is here, and the milliseconds, the marker intervals also mentioned here. So this MS is the annotation for Medtronic devices. This means the mode switch has started, and mode switch end also the same kind of annotation will come. So I will advance these things. So the now obviously, as we discussed, the device will check for the beats which is going to coming lesser than the mode switch interval. Here you can able to see the first beat, it is not like came into the interval. Second beat is also obviously not in the interval, lesser than the interval. The third beat, so now it is in the obviously mode switch interval, which is lesser than the program detection rate. Here 1 bar 3 satisfied and 1 bar 4 2 bar. So at last here, so out of 7 the 4 beats has satisfied. So now we are entering into the device is entering into the mode switch.
So out of 7, 4 bit or in any 7 it is going to take,
at least 4 beats should satisfy, sir. 4 beats, correct. It's in a rolling window.
If the fourth beat is not in the range, what will happen? Again, it will start.
Again, it will start for then that means the 8th beat it should be in the range.
It will wait for the 8th.
It will wait for the next 8th beat. So it's a kind of rolling window. So the first in, first out. The once it goes to the 8th beat, this first beat will get expired.
So in the 7, any 4.
Any 4 should get matched, sir.
It is not that
Consequent 4. Nice. So yeah, here there is one of like couple of things we need to note here. If the interval, no, obviously.
Your company versus other company, what is the major difference?
Sir,
it is for everything, or what is the innovation and for yours?
Correct, sir. So as long I know, the Medtronic has, it's a kind of 4 bar 7. We know, you know that regularly, even in ventricular arrhythmia detection and atrial arrhythmia detection, we will go with this kind of beats count. In other there are several companies we can able to see in seconds. So if the atrial arrhythmia passes for 1 second or 2 seconds, it will get like the detection will happen. So as per manufacturer, it will change, sir. So yeah, so here we need to monitor. Here is, we know only 4 sequences are there, that is ASNs, VSNs and APS, VPS, and like ASVP and APVS. Here you can able to see the ASAP and ARAP. The interval is coming like this, means then it is not counted in this like detection. Yeah, ARAP it will not get counted. So whenever the atrial pacing is comes, it can't able to count into the. AR is refractory period, sir. But the next beat it is coming in the AP. So that means you are pacing in your lower rate interval. So that means there is no arrhythmia according to device. Even if it is under sensing happening also, so that is one of the kind of drawback. So the same thing we seen here. So then the third thing is the detection duration. It's a time delay. So exactly here what will happen, sir, after the mode switch has detected, the timer has started. So because that is the one we are going to see in the diagnostic history, like how long the mode switch has happened, so that it will happen. So after that, the device will continuously monitor for the like A to A interval, which is when it is going out of the detection rate. Once it comes within the box, then it will switch to the normal mode. So before it's switching, it will confirm the criteria that I will show you here, sir. So here there are modes. So here we will have doubt. We will program the device into DDR mode. Obviously, it will go into the DDIR mode only. Here the interesting thing, even if you program the device at DDD mode, it will mode switch to DDIR mode only. So and even if the atrial tracking mode at VDD, it will go to VDIR. And if you program obviously MEP mode with rate response or non-rate response, so it will end up with DDIR mode only. So for Medtronic, if it is in the D operating mode, it will be obviously DDIR mode. And some of the thing is even Medtronic non-rate response devices like our old generation devices also, if it goes to mode switch, means it will end up in DDIR mode only, sir. That has accelerometer sensor, but it is not, approved for using in permanent mode, sir. So that is the thing, sir. Yeah, the fourth step, after the mode switch detected the ventricle rate, it will continuously track the ventricle rate, how it is going, everything. So here you can able to see all in a single like schematic intervals. The upper, the sensor rate is here, and the upper tracking rate, it goes immediately. The atrial rate is increases. Then the ventricle rate is limited till upper tracking rate. So once its mode switch is done, after that step by step, rate smoothing is applied, then it's stepping into the sensor indicated rate. Because after mode switch, we are going into DDIR mode. So after that, your sensor is going to drive the ventricle rate. So here your sensor is driving automatically. Here you can able to see schematically when atrial rate falls down below the detection rate, then automatically the sensor it's getting relieved from the sensor indicated rate, and it started tracking the atrial rate. So once it's fell below the upper tracking rate. So how it is device is going to detect when the atrial arrhythmia is terminated or not means it's based on again the AA intervals. So what it will do, it will wait for 5 consecutive atrial pacing, or the rate is gradually. Then what it will happen, the rate will obviously if the AP comes, then the rate is little like way below than the reduction rate. So then device will switch into normal modes.
This four has been fixed or it can be changed out of four, 4 out of
No, it's a company fixed one, sir. And there are some
even for the reversion to the normal mode is DVD mode again. 5 is fixed.
Fixed, sir. Fixed.
So we can't change.
We can't change it, sir. So here, some of the, here how DDAR mode is going to explain, that is there mentioned here, sir. So DDAR mode, yeah, we all know that's an on-tracking mode. Whenever the atrium is spaces, it will give AV synchrony. Whenever the atrium is senses, it never give AV synchrony. So in simple terms, that is DDAR mode. It's a kind of VVAR mode as well. Yeah. So here there is one schematic diagram for atrial. It's a kind of flutter, and the device here you can able to see it's a mode switch happened. So after that the flutter stops here. Then device has continuous atrial pacing of 5 beats. So then after that here you can able to see MS. So mode has been switched. Then the normal mode, whatever the programmed mode, it resumes. Mode switch ends. So this is all about mode switch. So in Medtronic there is an additional algorithm to enhance the mode switch feature, that is called blanked flutter search. So blanked flutter search, we will call it BFS. So this blanked flutter search will be nominally turned on in Medtronic devices. So what is the need of this? When obviously we know there is a mode switch algorithm is there. Then what is the need for this blanked flutter search? The question will rise. So the thing is, people, after the mode switch algorithm, we realized that not only patient going to have atrial arrhythmias like AF, may patient have atrial flutter as well. So that time we all know atrial arrhythmia is an A to A interval. Obviously, it will vary like anything, but in flutter it's all very sequential. So that flutter can easily fake the pacemaker this detection algorithms. So one beat it is falling in the atrial sensing means the other beat if it is falling in the atrial blanking period. So obviously the device will not see it is falling in the blanking. So what it will do, every alternate beat device will miss. And the other flutter bit it will miss, again other flutter bit it will track. So if the flutter is going on 300 beats per minute, according to device it's 150 beats per minute only. So then device will track the ventricle at a higher rate. So to avoid this, so they came up with an blanked flutter search. I will show before going into that. I can show here, sir. The schematic thing you can able to see, we know that the flutter is going on here, but we can't able to see any other markers in the marker channel. Only ASVP it is tracking like our regular like normal sinus. But at some point of time you can able to see the device has done mode switch, and after that you can able to see it's the atrial rate is sudden increase in the atrial rate. So how we are detecting the blanked flutter here means so we are going to take the total atrial blanking here. So the total atrial blanking is our sensory AV delay plus post-ventricular atrial blanking. So for an example here, our AV delay is 150 milliseconds and blanking period is 180. So your total atrial blanking period is 330 milliseconds. So here what we are going to do is, so obviously now we know that other alternate atrial bit is falling into this blanked flutter only. So here we are finding out what is our actual A to A interval according to device, which is 600 milliseconds. Now we are going to multiply the total atrial blanking into 2 times. So then it will come 660 milliseconds. So now we know the A to A interval and this our calculated interval as well. So if the atrial interval it falls lesser, it comes lesser than the total atrial blanking period, then the device will increase the PVARP in the after 8th beat, sir. It will see for 8th beat. So after 8th beat, it will increase the PVARP. So if the PVARP is increased, the other atrial, other flutter bit, it will fall in the refractory period. So if it is falling in the refractory period, then other atrial bit, it will come in the very shorter interval. So then the device will switch into mode switch. The exactly same thing happened here, sir. I will show you here. This is the first bit, second bit, third bit. You can able to 4, 5, 6, 7, and 8. So after these 8 beats, the device has found out this interval is not matching, is lesser than the actual the total atrial blanking period. The 9th beat, what it is doing, sir, you can able to see it is increased. I'll show you here. PVARP extends, causing an AF. So if the PVARP is not extended, means Here AR will not come. Again, it will get blanked. Then the second other bit, atrial bit will get tracked. So because of this AR is happening, the next AIS is also uncovered. So now the interval is very short here, which is lesser than our reduction interval. So the device has done the mode switch here, sir. So this is it will be helpful for the patient who has continuous flutters. So the criteria is here is mentioned. So how a device will see, it will monitor the 8 consecutive A to A interval, and it will see each AA interval is like 2 times lesser than the total atrial blanking period. I mean the total blanking atrial blanking period, which is our SAV plus PVAB. So on what after that, what it will see, it should be half of the A interval is lesser than the detect rate interval, the 8th beat. If it is not that, then it will not switch. So after that, it obviously extends the PVAB in the 9th interval to uncover the blank days. So after that, the mode will be switched to the non-tracking mode. So these are the two modes of Medtronic in mode switches and blank flutter switch. So these are our nominal parameters. So mode switch will be nominally turned on. The detection rate will be nominally 175 beats per minute. So on detection duration, we can be able to program here. I mean, how long you need to wait to detect the things. And blanket flutter switch will be obviously nominally turned on. We can turn it off if we don't require means. So this is the Medtronic programmer screen. Here you can able to see in the second line, you can able to see the mode switch rate. You can open this and you can able to blank flutter switch, which I discussed now. You can turn it off if not required. And reduction duration, obviously it will be no delay in the nominal parameters. If you want your patient to be more time in AF and I want to detect a late, you can turn it on. And detection rate you can program, and if you don't want mode switch, you can turn it off as well.
EHR and mode switch are totally different.
Sir?
EHR and mode switch, how they are different?
Sir, I mean the mode switch rate obviously we can able to change, but that other one we can't able to change, right, sir? Fixed, sir.
So it is a detection, it will just keep in the information.
Correct, sir.
But it is not taking action.
It's not.
So EHR normally how much you are keeping in Medtronic?
Come again, sir. That
EHR rate, how much it is being kept?
it is 175. It will be fixed, sir. Here, I mean, once the rate crosses this interval, automatically it starts recording the EGM as well, sir. So we can't discriminate both.
So as such, AHRE, what action is taking the mode switch? And if AHRE is happening without mode switch, it is going to be captured in like 3 or 4 bits at a time.
I mean, older devices we can't able to turn on that, sir. But in now like newer generation devices, it has separate option for arrhythmia monitoring and things. I need to cross check once that. Let me check once, sir. So whether without mode switch, whether we can able to record the EGM or not, I'll check that, sir. So yeah, finally we can able to see here in our data collection setup to see the high rate episodes, whatever it is there. So Medtronic devices can able to store 16 up to last 16 atrial high rate episodes based on mode switch criteria and first in first out concepts. And this is the data collection setup where you can able to see again how much you can customize your things recording storage setup set here. I mean how much time you want the episodes and data should be cleared. It's EGM type, what EGM type you want, whether it's only atrial EGM or it's both A and B summed EGM. So those things you can able to customize here, which we will very rarely we will use to customize. Most of the time company nominals will be there. Yeah, we've seen this already, same thing. So and this plot also will be available. You can able to see, I mean, how we are interpreting the ventricular arrhythmias like that. So and there are some knowledge checkpoints, so which is based on company things. So this is all about mode switch.
Okay. So one thing, this is regarding the virtual pacemaker. What about the CRT and I series?
So same concept in CRT and I series. So
usually in CRT, the patient is having how the device is going to switch over to VVI mode suddenly. Patient is having 10 mode switch.
Okay, sir.
In what critical point it will say that either it is goes by default that after 10 mode switch it should go into the VVI or DDI mode, or there is some means we have to do from our side that okay, most of the time patient is doing AFib mode. It's a mode switch, we should switch over to this one. So there is any automatic mode?
So automatically here it will not help, sir. Whatever the endpoint what we can get it If the patient has remote monitoring, then obviously we will get notification if the patient continuously goes into AF. If AF comes, obviously the patient ventricle pacing may go down. So after that, if ventricle pacing goes lesser than 90% by pacing, then we will get alert in remote monitoring devices, and as well in normal device, if not remote monitoring, also the observation screen will have the alert. The next interaction we can find it out, and we can permanently switch into VVA with a higher rate. And conducted AF response is an algorithm, sir, where it will help you to regularize the V to V interval. So, and ventricle sensor, obviously VSR will not help here because it's an AF. So this algorithm, by using these algorithms, we can increase the YV percentage little more, but automatically there is no algorithm. No, there is no automatic algorithm.
To VVI mode permanently, if the patient is having particular number of modes?
No, sir.
Nothing is there. Any company is having, or it's not?
That I need to verify it, sir. Other companies.
Sure. Summarize it.
Thank you so much, sir.
Thank you, Anand. Regarding just summarizing what he has told, making it more simple. So whenever we are implanting the pacemaker is having, the purpose is, pacemaker is that it should take the action when the heart rate is going down. For the most of the time, it is called demand mode pacemakers. There are situations when we want to track the atrial events and it should go to the ventricle, but due to the AV block, it is not happening. So we have to track. So this type of things we get in the AV block patients who is having a good sinus function. So if the patient is having good sinus function, in that situation, we don't want the pacemaker. In that, we don't want that the pacemaker should utilize the pacing. So sinus rate is there. We have kept that, okay, at 70 rate, till the 70 rate is there, the sinus rate should be tracked to the down, or you can say ventricle. So that is called tracking mode. So when we are implanting dual chamber pacemaker, we are doing what exactly? We are changing two modes. One is the tracking mode, means when the atrium is functioning well, sinus is functioning well, the rate should come to the ventricle, whatever the natural rate is there. And second is the called inhibitory mode. Inhibitory mode means whenever the atrium is been sensing a fast atrial rate, it should not come to the ventricle. So it should disconnect it. So this disconnection is needed, and normally the disconnection is a very smooth process. The time it is going to detect a particular number of atrial events or atrial beats, which is coming faster than, which has been what Anand was showing, 175, means A to A interval is coming 343 seconds, means the atrial lead is sensing that the rate of atrium is more than 175. It will say, no, we don't want to pace the ventricle at this rate to make the patient safe. This is the purpose of mode switch. So it is not going to take on the one beat. So it will start counting it. Like we are counting a 1, 2, 3, 4, now run. So in this, the Medtronics or most of the devices having 4 beat they are going to count, which is falling in that window. So first beat, 175, second beat, 175, third beat, 175, fourth beat, maybe it 150. So it will again wait for the next beat. Then it has come 175. Okay, now we should go ahead with our mode switch. Immediately it will change. And mode switch, what will happen? The particular rate, what we want, the ventricle rate. Some patient, maybe we will be asking the ventricle should pace at 60, somebody will be 70, somebody we will be asking 80. But nominally, what I know most of the time, it is 80.
Yes, sir.
80, because atrial rate is very fast. All of a sudden, if you are going to 60, the patient may be having a difficulty to one. So it keeps the rate in and around 80. Most of the companies are having 80 or 90 or 70. In 70 to 90 in between, it will be there. 80 is the nominal. So it will pace at 80 till it senses, and this is VVI mode. So here the ventricle is pacing, atrium is going on atrial fibrillation, it is forgetting whatever you want to beat, I am not going to track down, and it is beating a rate. So you will say the heart rate is at 80 rate, and there is no A pace, means there is no atrial pacing is coming. So this situation will go till the device again senses. Sensing is going on. Up is sensing, down is pacing. The time it senses that 5 of the beats has come into the normal range, it will say, okay, now we should switch over to tracking mode. And then it will be again DDD mode. So there is a switch between the DDD to DDI mode, and this switching will be happening when the device capture a particular type of atrial event, which is we can say 4 or 5 beats, which is out of the order, it will say there is something happening in the atrium. It may be atrial fibrillation, and atrial fibrillation should not be tracked to the down, because atrial fibrillation rate is how much? 300 to 350. So it will convert it to ventricular fibrillation. Even though the device is having higher tracking rate, is a different, but patient will be more symptomatic. So we don't want a heart rate of 170, 180, 190, the patient, because he will be having suddenly palpitations. So we wanted to, this is the reason. And what one more, he told that in the pacemakers from Medtronic, they are having one thing, what we call as atrial flutter detection. Flutter is one of the arrhythmia which has been missed by most of the devices, because the rate is regular, number one. It is a regular tachycardia at a very fast rate. So what happened? The device is not able to detect the every alternate beat, and it will start tracking it. So this atrial tachycardia, atrial flutter, they are having algorithm in which they are going to just change the things so that out of some window which is not been captured by the normal mode, it is going to extend the PVARP we call as a PVARP, so that it should detect if some beats are falling in the PVARP and it is look like to be flutter, means artificially it will create that you are looking at a flutter, not fibrillation, and immediately stop the tracking, and that is the way it will alert, okay, now mode switch. So mode switch is basically meant for the any atrial arrhythmia where the heart rate is going more than 175, it will start non-tracking mode, or flutters where that is particular mode will be getting switched on. And this is in Medtronic, and the detection rate should be very fast. The patient is started and you are mode switching after 2 minutes, 3 minutes, that is not acceptable. So usually 2 to 3 seconds we have to switch on, device should switch on, so it will detect, and everybody is having their own algorithm. So number of counting beats, how they are counting the beats, every alternate or consecutive beats they are going to detect. Any questions? So same thing is for the ventricle, from the CRT and ICDs. So anything DDD means dual chamber, dual sensing, pacing, and what is the two responses is needed. It should have the tracking and sensing. If tracking and sensing both are there, then we are saying dual. And how D to I is going to convert, it is depending upon the atrial events. If atrial is going very fast, it will do, okay, I don't want to go in DDT. So tracking is gone and it is going in inhibition mode. Okay? Yeah, DDI. So thank you so much. See you next time.